Yeah, I tell you what, anytime you get to solve logarithmic equations, it is the best day of my life. Anyway, today, just to kind of summarize where we've come from the last day or two, we're going to review and dig a little deeper today. We're going to see basically two things happening. There's two types of equations we're going to investigate. Number one is if we see logs on only one side. Okay, emphasis on just one side of the equation. The second type that we might see is if we see logs on both sides of the equation. Again, emphasis on both sides of the equation. So we're gonna, every time we do a problem tonight, we're gonna, first of all, we're gonna start off with identifying which of these two categories it falls into. Do we have logs on just one side, or do we have logs on both sides? Okay, so we're going to get our steps all in order here. And the first thing I want to take a look at is what happens if we have logs on just one side? Or, more specifically speaking, what if not every single term contains a log? Okay, so some of the terms have a log and some don't. A great example of that is the one I've imported over here in the black ink here. The first term right here has a log, the second term has a log, but the third term over on the other side of the equation does not have a log. So really what we have is logs on just one side. How are we going to approach this type of problem? Well, the first thing we're going to do is we're going to gather each term with a log on one side, which in the example above has already been accomplished. And then we're going to condense. That is that's a huge word tonight. We're going to be very proficient at condensing. What does it mean to condense? Well, we're going to use a combination of our product law from the other night. Possibly we're going to use our quotient rule quite a bit. And do you remember the name of the third one? Yeah, it was the power law. And so we're going to use a combination of these three laws throughout the problem tonight. And we're just going to keep condensing. Now, one of the things I want you to get down here is when you condense, you are allowed to write the word log one time. We're only allowed to write the word log one time. That's something we're going to continue to remind ourselves. That's probably been our biggest Achilles heel in the past. Number two, we're going to convert this logarithmic equation into an exponential equation. And basically when we say we're going to convert it to exponential, we're saying we're going to go around the world. Alright, and third step is to check for, get this is a wild word, extraneous solutions. What does it mean to be an extraneous solution? Basically a number that violates the domain and doesn't check. So the word extraneous basically is any solution that violates the domain. So we're going to check our domains each and every time, just like we did last night, and possibly come up with some rejections. Alright, so our first example here tonight, I think it's very clear. There's a grand total of two terms, one on the left side, one on the right side, but not every term has a log, just the ones that are on the left. So I'm going to go ahead and I'm going to solve this with two different methods. And this on this screen here, we'll call this method number one. And with method number one, what I'm going to do is I need to address this coefficient somehow. In method number one, I'm going to divide both sides by 2 right away. Divide this side by 2, divide that side by 2, these cancel, and I now have log base 4 of the quantity 5x, and we've done a great job of pronouncing these correctly lately. Now that I've addressed that 2, I'm going to go around the world. I'm going to convert it to an exponential. I'm going to grab the 4, I'm going to raise it to the 3/2 power, and I'm going to set it equal to the quantity 5x. And if around the world is a little confusing still, just do exactly what I did. You know, circle the 4, draw the arrows, talk yourself through it. Let's make sure our handwriting is impeccable so that the 3/2 actually looks like an exponent. And I'm going to use the groundhog rule to evaluate 4 to the 3/2 power. That is the square root of 4 to the 3rd. Let's see, square root of 4 is 2. 2 to the 3rd is going to be an 8. Of course, we could always revert back to the calculator for that one. Now I'm going to just divide both sides by 5, and my final answer is going to be 8/5, which is approximately 1.6. Alright, and I'm just going to go back and check the domain. The domain basically said as long as this quantity is positive, as long as 5x is greater than 0, divide both sides by 5. As long as x is greater than 0, we're good, and the answer that we just had was certainly greater than 0. Okay, now method number 2, notice I've copied down the exact same problem. and I'm going to start at the very beginning, and this is called method number 2. Again, I have to address the coefficient. What I'm going to use is I'm going to use my power law. What does the power law say? That was the third log law that we talked about. The power law said that the coefficient can move to the exponent. So I've got the log base 4, and then the entire quantity, 5x, is being squared. Okay? And what does it mean if I square both of those terms? That means I get 25x squared equals 3. And now I'm just going to go around the world here. And I'm going to say that 4 raised to the third power equals the quantity 25x squared. 4 to the third. What is 4 to the third? Hopefully we're feeling comfortable with that. That's just a 64. Now I'm going to divide both sides by 25. And it doesn't really give me a clean number, and that's okay. We're just going to leave it as a fraction. That doesn't bother us, because what's going to happen next is I need to somehow cancel out that squared sign. So I'm going to take the square root of both sides, and that gives me 8/5 equals x. Again, it's the same answer we got last time. It's just 2 different methods of addressing that coefficient, and you could pick whichever method you like better. Here's one of my favorite examples. I tell you what, students usually absolutely wet their pants when they first see this problem. It's a very intimidating problem when you first see it. Again, your handwriting is going to be impeccable, but I'm going to say there's only logs on one side again, just on the left side, not the right side. So just logs on one side. And this one's already fully condensed for us. So what I'm going to do is I'm going to instantly go around the world. I'm going to say the x plus 3 is my base, or my subscript. I'm going to raise that to the second power, and I'm going to set it equal to this obnoxious quantity. And you could put a set of parentheses in right there if that makes you feel better. So we've got the quantity x plus 3 raised to the second power equals x cubed plus x minus 2 all over x. Wowzers. Okay, where do you want to go next? I want to go ahead and I want to square this, so I'm going to have to FOIL it out. I'm going to get x squared, combine the outer and inner terms, and then finish with a plus 9. Wow, man, this is really a big-time problem. Where do you want to go next? What's your gut tell you? I'm thinking I'm going to put this trinomial over 1, and I'm going to cross-multiply product of the extremes equals the product of the means from last year. Make sure that this x gets distributed all the way through each of these terms. So we're going to end up with x cubed plus 6x squared plus 9x equals x cubed plus x minus 2. Love multiplying by 1. That's like the greatest thing in math. Now I'm going to subtract x cubed from both sides, which was awesome. Those terms simply cancel out. We'll go 6x squared, just clean it up a little bit. X minus 2. All right, now are you solving a linear or are you solving a quadratic equation at this point? I would say I'm solving a quadratic because of the squared sign. So I just want to move all the terms over to one side and set it equal to 0. So I've got 6x squared. If I subtract an x from both sides, I get 8x. And if I add 2 to both sides, I get plus 2 equals 0. Do you have a GCF? You do. And I'm going to divide both sides by 2. I get 3x squared plus 4x plus, don't forget the 1, equals 0. 0 divided by anything is 0. Now hopefully we'll keep our fingers crossed and hopefully hope it factors using some guess and check. I know it's 3x times x because 3 is prime. Multiples of 1, I need a positive 1 here, positive 1 there. If I check it, 3x plus 1x does equal 4x, so I'm good to go. Let's go ahead and tee this one up. I'm going to go nice and slow. I'm going to say, let's see, if 3x plus 1 equals 0, that means 3x has to equal negative 1 and x equals negative 1/3. We'll go back and check that one here briefly to see if it satisfies the domain. If x plus 1 equals 0, x has to equal negative 1. So we're looking to see if negative 1/3 and negative 1 are acceptable answers. So scroll all the way back up here. And with 2 things. We have to make sure that both the base is positive, which if you do negative 1 plus 3, it's positive, or negative 1/3 is the same thing. And then we're also going to plug it into this quantity right here to make sure it's positive. And certainly we could make use of the calculator and verify that substituting a negative 1/3 or a negative 1 into all those x's does indeed make this a positive quantity. So that's a good thing. My solution would be negative 1/3 and negative 1. Okay, next example. Okay, first question that goes through your mind is, do we have logs on just one side? Got a log on this term, got a log on this term, but I do not have a log on this term. So I'm saying yes, we do have logs on just one side. And so what does your notebook say? It says we've got to fully condense the left side. And in order to condense the left side, which of the three laws are you going to use? I'm going to use, because I saw a plus sign, I'm going to use the product law. And that just means as I combine these terms, I'm going to basically be working with multiplication. And also remind yourself that as you condense, you're only allowed to write the word log one time. So I'm going to have log base 4, and then here I'm going to multiply this x times this x minus 12. Just multiplying the inner functions together, distribute the x, and I get x squared minus 12x. Once I've got it fully condensed, I'm going to go around the world. 4 raised to the third power equals the quantity x squared minus 12x. All right, because I'm solving a quadratic equation that contains a squared, I'm going to take this 64 that's right here, and I'm going to subtract it to the other side, set the equation equal to 0. Keep your fingers crossed that hopefully it factors. Oh my goodness, what adds up to negative 12 and yet multiplies to negative 64? How about 16 and 4? Now, here's what you know. Because this is a minus sign, I need one of the numbers to be positive, one of them to be negative. I'm going to go with negative 16, and then if you add 4, you'll get the negative 12 right there. Let's go ahead and we'll tee it up. And I've got x equals negative 4, x equals positive 16. Let's go check them with the domains. All right, how'd the domains go? I'm thinking this domain is all x values greater than 0. And this domain is all x values greater than 12. So guess who doesn't pass the test? And all you gotta do is fail one of those domains and you get rejected. Yeah, we're going to reject the negative 4. And then we will keep the positive 16, and that's my only solution. All right, now I got a much tougher question for you here. Got a little bear trap in it. And start off with this question. Do we have logs on just one side? Well, kind of. And this is where the bear trap is. The first term has a log, the second term does not have a log, and yet the third term does have a log. So go back to your notes and look at one of the very first step we wrote down. We said we've got to gather every term that contains a log on one side. So my very first move here is I'm going to slide this down a little bit. Actually, I'm going to slide it up. Okay, what's my first move? I'm going to try to move this log base 6 to the other side. I'm going to add that term to both sides. These logs are not like terms, so I can't really combine. I'm going to keep them separate. I'm going to say log base 6 of x plus log base 6 of x minus 1 equals 1. So officially I do just have logs on one side, but I had to take a little work to get there. My next move is I want to condense the left side. Which law are we going to use? I believe we're going to use the product law, which means this plus sign is going to become multiplication. I'm only allowed to write the word log one time, and I'm going to multiply the inner functions together. Now I'm going to convert it to exponential form. How do you do that? Very easily. We go around the world. 6 raised to the first power equals the quantity x squared plus x, so we're getting much better at that. It's quadratic, so I'm going to set the equation equal to 0 by subtracting the x. Does it factor? Oh my gosh, does it ever factor? X minus 3 times the quantity x plus 2. We're motoring right along here. Let's tee this puppy up. We're going to say that x equals positive 3 and x equals negative 2. We're going to check for what? We're going to check for extraneous solutions, solutions that violate the domain. Does 3 violate it or does negative 2 violate it? Let's go check. This first domain right here, we're going to say that x has got to be greater than 0. And this domain here says x has got to be greater than 1. So I'm thinking we're going to reject the negative 2. We are going to accept the positive 3 as our one and only solution. Okay, our last problem with logs on one side, and again, log on the first term, log on the second term, but no log on the third term. We've got logs just on the left side. Now, as far as condensing goes, the order in which we condense is extremely important, okay? Condensing, step one, we're going to use the power law first. That's extremely important, as I just said. And then once we use the power law, I guess the word rule would be suffice, we're then going to use the quotient law. Let's really emphasize in our notebook that the order in which we use these two laws is important. What are we doing with the 2? Boom, move it. What are you doing with the 1/2? Boom, move it. So the first term becomes the log base 3 of x squared minus log base 3 of 16 raised to the 1/2 power. What does it mean to raise something to the 1/2 power? Well, it means we're taking the square root of that term. And so I'm going to rewrite that as radical 16. We're going nice and slow, taking some baby steps. Now and of course, the square root of 16 becomes a 4. So from now on, I'm just going to assume that that term right there is a 4. The quotient law says, because I see a minus sign, I'm going to write the word log one time only. And I'm going to write x squared divided by 4, which used to be the radical 16. We've got it fully condensed, so let's go around the world. Let's convert this to exponential form. 3 squared equals the quantity x squared over 4. All right, what do we got here? 3 squared equals x squared over 4. Let's multiply, of course this is a 9, so we'll multiply both sides by 4, and we got 36 equals x squared. Oh my goodness, I'm shaking in my boots just thinking of a popular mistake we've seen a lot. What if I took the square root of both sides? Do you have any problem with what I wrote on the screen right now? I got a monster problem. You know what I forgot? I forgot the gosh darn plus or minus sign. We've got to have 2 solutions. Let's go back. We'll check those domains and see if there's any violations been committed. Right here, the domain of this term, we're going to say x has to be greater than 0, so we're going to reject the negative 6 and accept positive 6 as my only solution. Okay, this marks our halfway point. We're halfway done with tonight's video. We're now going to investigate equations where there's logs on both sides. In other words, what we're really saying is that every single term contains a what? Yeah, every term contains a log. So here's a great example to look at here with the blue background. We've got the first term's got a log, the second term's got a log, the third term's got a log. We've never seen that up to this point in tonight's video yet. So how are we going to handle these? Number one, we're going to condense both sides. And that's essentially the same first step we had on the last set of questions. Here's where it gets different though. We're going to cancel the logs. Once you condense it, we're going to cancel the logs and essentially set their inner functions equal to each other. Whatever's inside the parentheses, their inner functions, we're going to set equal to each other. And then again, we got to check for extraneous roots. We've been doing a lot of rejecting tonight. We've seen a lot of solutions that violated the domains. At first glance, I think it's easy to identify every single term. All 3 of them have a log in them. So what I'm going to do is I'm going to condense. And which law are you going to use as we condense? When I see the plus sign, I'm thinking of the product law. And this one's going to get a little feisty because I got to multiply the x minus 2 times the x plus 3, and I'm going to have to do some foiling. So you can make a little note there. We'll definitely see some foiling in class tomorrow. I'm only allowed to write the word log one time on this side. As I FOIL, I'm going to get x squared. Combine my middle terms, I get plus 1x. Finish with minus 6 equals log base 7 of 14. Here's where things get different. I'm not going to convert it to exponential. What I'm going to do is I'm going to cancel the logs, and I'm going to set their inner functions equal to each other. X squared plus x minus 6 has to equal 14. I want to set the equation equal to 0. So x squared plus x minus 20 equals 0. Look at how nice this one's going to factor. We've really been blessed with some very easy factoring tonight. Tee this one up, and x equals 4, x equals negative 5. Let's go see if either one of these solutions violates the domain. Does Okay, what are our domains? I'm going to say the domain right here is all x values greater than 2. Right here, the domain is all x values greater than -3. We have to appease both of these domains in order to be considered a solution. I think we are going to reject the -5, but accept the +4. So there's my one and only solution. Okay, right off the bat, what did you say? Did you say that there was logs on just one side, or did you say that there was logs on both sides? Every single term possesses a log, so I'm going to say there's logs on both sides. Where does my condensing take place? My condensing is going to take place right here on the right side this time. And as I get ready to condense, which law do you want to use? I'm going to use the quotient law. All right? So I'm going to just rewrite the left side, log base 4 of the quantity 2x plus 1 equals, you're only allowed to write the word log once on this side. The minus sign says I'm going to divide x plus 2 divided by 3. Here's my favorite part, cancel the logs and set the inner functions equal to each other. 2x plus 1 is going to equal x plus 2 over 3. What do you want to do next? Let's go ahead and cross multiply, shall we? So let's say we got 6x plus 3 is equal to x plus 2. Ooh, this is maybe the first one all night where it wasn't a quadratic. There is no squared signs. So what I'm going to do is I'm going to gather my x's on the one side, and then I'm going to gather my non-x's on the other side. That's going to give me 5x is equal to -1. I'm going to divide both sides by 5. X is equal to -1/5. And we're going to go back and see if we can accept the -1/5 or not. A little trickier ones here. I'm going to say that x has to be greater than -1/2. I'm going to say that x has to be greater than -2. So ultimately the question becomes, is our solution -1/5 greater than both of these key numbers? And I want you to just visualize yourself a number line, and on that number line, let's say there's 0, there's -1, there's -2. The -1/2 would fall right there. Guess where the -1/5 would fall? That would fall right there. So our answer is bigger than both the -1/2 and the -2. So I'm going to accept our solution. We do not have to reject this negative number. It is acceptable. Alright, our last example tonight, we're finishing strong. We take pride in finishing strong. Nobody's going to outwork us, that's for darn sure. And of course, I've saved a nice bear trap for you here at the end. We've got logs in every single term, but what is the bear trap? This darn coefficient right here. Alright, let's make a real, we've got to look out for these coefficients. Look out for these coefficients. And so as we get ready to condense, there's going to be 2 steps to our condensing, and the order is really important. We're going to use our power law first, and then second of all, I'm going to use my product law because of the plus sign that separated the 2 terms right here. But anyway, let's just start with the power law. Where can this 2 go? We're going to send it right up here to the exponent. That's where I'm going to move it. So I've got log base 3 of 2 plus log base 3 of x squared. One little side note that I haven't mentioned yet, every single one of these logs has a base 3. That's something that I kind of took for granted. It will be true every time for us, but if you went to, when you get to higher levels of math in college, they may try to mess with you and change these bases on us, but that won't be the case this year. Alright, so I just did the power law, now it's time to do the product law. Plus sign means multiplication, so it's the log base 3 of 2 times x squared. Notice I only wrote the word log one time on the left side. This is my favorite part. We're just going to cancel the logs, and we're going to set their inner functions equal to each other. So we're going to say 2x squared has to equal 7x minus 3. It is quadratic, so let's move all the terms to one side. And again, this, if I get to going too fast, you gotta be disciplined enough to hit the pause button. If I'm going too slow, then by golly, pause it, solve it on your own, come on back and check your answer with me, just to make sure you're challenging yourself appropriately. Little guess and check here, shall we? I've got to have the same signs because I'm working with a plus sign. I'm going to go -3, -1, and I think that works beautifully when I check the outer and the inner terms. We're going to tee this one up. I've got x is equal to +1/2, x is equal to +3. We'll go back and check those domains. +1/2 and +3. Let's see what we got cooking here. This x value has to be greater than 0. Notice I'm checking it with the original equation before it got squared. And this x value right here is got to be greater than 3/7. Question is 1/2 bigger than 3/7? Well, 1/2 is equivalent to 3.5/7, so I'm thinking yes, it's bigger. Again, you can always turn those into decimals too if you want on your calculator to see who's bigger. That's probably the easiest thing I should have said. So anyway, we don't have to reject either one of our answers. They're both great. We're gonna keep them both, and we're good to go. So what do we got to know before we walk into class tomorrow? We've got to be very good at condensing all of our log functions. We've got to determine whether there's logs on one side or both sides, and the differences on how we're going to handle those equations, okay? Good luck tomorrow. We'll see you ready to rock and roll.